Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on October 20th, 2025, about 2 days ago. The big hook is that this paper reframes progress in world modeling by testing success in closed-loop tasks, showing that controllability matters more than visual polish. The paper is titled World in World: World Models in a Closed-Loop World. And as we will see later, the implications for evaluation and training are quite significant. In short, the work introduces a unified planning loop and action interface, curates 4 embodied environments, and shows that post-training on action observation data and more inference time compute drive real gains. So, Figure 1 presents the platform at a glance, emphasizing that models are judged by closed-loop task success rather than pure visuals. The left panel lists diverse video generators that plug in through a unified action interface, which feeds into an embodied policy for control. The right panels depict 4 task families, covering active recognition, navigation, question answering, and manipulation. The bottom section introduces a leaderboard and 3 analyses: data scaling, inference time scaling, and the weak correlation between visual quality and task success, which together frame the key research questions. Alright, Figure 2 shows that task success rises unevenly with generation quality, meaning pretty videos do not guarantee better decisions. The chart compares a visual quality score on the horizontal axis to success rate on the vertical axis. The blue post-trained models, which means fine-tuning on action observation data, sit higher in success, with 1 point near about 63%. Several zero-shot points appear visually strong yet underperform, so controllability drives utility more than aesthetics. Well, Figure 3 shows the closed-loop planning pipeline that turns a video generator into a useful world model for decision-making. The agent proposes several candidate action plans, which are simulated to predict what would happen next. Those predicted rollouts are counterfactual futures, meaning imagined outcomes under different choices. A revision step scores the rollouts and selects the best plan. The chosen action sequence is then executed in the environment, which closes the control loop. So with the planning loop in mind, Table 1 reports how world models change performance on active recognition and image goal navigation. The left block shows that post-trained video generators lift recognition accuracy above the base policies, with one method around 63%. The right block shows navigation success rises and routes get shorter, with the best open-source post-trained model near 45%. The metric SPL means success weighted by path length, which rewards reaching the goal with efficient routes. Alright. Figure 6 shows that adding more post-training examples steadily raises success rate. Post-training here means fine-tuning the video generator on action and observation pairs so predictions align with controls. WAN 2.1 post-trained climbs to about 63%. SVD post-trained reaches about 61%. The trend suggests larger models benefit more and stall less, which signals real capacity to absorb action condition supervision. Wrapping up, 2 takeaways stand out. Controllability beats visual polish for embodied success, and both post-training on action observation data and more inference time compute deliver sizable gains. The broader implication is a shift toward closed-loop benchmarks and training recipes that make simulators actionable for planning and control. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.